Hello everyone, welcome to the official YouTube channel of NSmart, and I'm your chemistry educator for today. This is our second video on hydrogen bonding. If you haven't watched the first video yet, I will recommend you to go ahead and watch the first video first. The link will be there in the description down below and also in the first pinned comment. So we are here releasing all this video in our Pariksha Sankalp series, where we are actually keeping in mind about the students who are preparing for CBSE, the upcoming examinations, right? So if you're someone who is actually, worrying about your upcoming examinations and you are here for the last minute preparation, you are in the right place. So let's get started with the topic for today. Today we will be continuing with the hydrogen bonding previous year questions. Like I said, guys, if you know about hydrogen bonding, then you keep watching this video. But if you feel like, sir, I don't even know what is hydrogen bonding, or maybe, sir, I do know, but sometimes I do make mistakes in hydrogen bonding. So under these circumstances, just watch the first video there. Like I said, the link will be there in the description down below. Now, let's get started with the topic for today, which is we have been solving these questions in the last class, and I will just give you a quick revision or the recap of the last topics that whatever we have learned there. See, I told you that hydrogen bonding is something which is a kind of a dipole-dipole interaction, an extreme case of it. See, I guess you know that there are intermolecular forces, right? So dipole-dipole interactions, which is also known as the Keystone force, the extreme case of that is going to be called as the hydrogen bonding. This much we are all clear. Now, that can be done only when if you have FON, these three elements, right? These three elements are only the ones responsible for hydrogen bonding. This much also we are aware of. Now, in the last session, I have told you how the hydrogen bonding is responsible for all the physical properties, correct? And also not only physical properties, guys. I think I have told you about the chemical properties also. There also the hydrogen bonding plays a vital role, and today we are going to talk about those kind of questions. As you can see, I told you in the very first moment of the previous previous video, that we will be solving 5 questions from the same year 2025, right? So there you can see, this is the first question we have solved in the previous class, right? Just a second. This is the question we have solved in the previous class, right? Ethyl amine is soluble in water, whereas aniline is insoluble in water. I hope you remember, guys. Both of them are capable of doing hydrogen bonding, correct? But how many? Can you just pause this video and give it a recall? How many hydrogen bonding can ethyl amine make, and how many hydrogen bonding can aniline make, guys? Very good. The answer will be 3. So both of them could make 3 hydrogen bonding, but still ethyl amine is soluble, but aniline is insoluble. What was the logic behind this, guys? Because ethyl amine, the carbon chain was small, right? Only 2 carbon. Ethyl means what? 2 carbon, no? So for ethyl amine, the carbons are only 2 present in there. But when you talked about aniline, how many carbons, guys? 6 carbons. Benzene, right? There is a 6 carbon system there. And you know that I told you in the previous session that whenever we have this carbon chain, they are what are they, guys? Hydrophobic. Very good. So they are hydrophobic, and because of that reason, what happens is, because of the benzene part of aniline, it doesn't get dissolved in water. Very good. Now we are going to talk about this particular question today. CH3 is more basic than CH3 in an aqueous solution. Guys, this is a particular question which has been repeatedly coming in the previous year examination. Okay, I'm gonna make you recall from where is this question. Can you give it a try? From which chapter is this question coming from? Organic chemistry, last chapter. I mean, nitrogen compound, right? Not last chapter. Last chapter is biomolecules. So from nitrogenous compound, this question is coming. Do you remember the original part of the question, guys? The original question was, you have a 3-degree amine, you have a 2-degree amine, you have a 1-degree amine, right? What is their basicity in gaseous state, and what is their basicity order in aqueous medium? Okay, this is the original question. So where will you find it, guys? You will find it in the last chapter, second last chapter, which is your nitrogenous compound, and there you will find this particular thing, 3-degree, 2-degree and 1-degree amine basicity ordered in gaseous medium and also in aqueous medium. I will talk about that today only. Right now, we are going to talk about that. So what is a 3-degree, 2-degree and 1-degree amine? For that, let me take you to the next page once. I need some more space here. See, this molecule over here, this is called, this is called ammonia, right? What do we call this molecule? Ammonia, correct? Now, what is a primary amine? See, whenever the degree is actually based on how many carbons it is attached to. So let's say instead of one hydrogen, I have given a CH3 group. Instead of a hydrogen, what have I done, guys? I have given a CH3 group. See, I have replaced this hydrogen with the CH3 group. What do we call CH3 groups, guys? We call it alkyl groups, right? We will call it alkyl group. So whenever we are actually substituting a hydrogen with an alkyl group, what we call that, guys? We call that a primary amine. This is your 1 degree amine. Why is it 1 degree? Because this nitrogen, my major functional group, is connected to 1 carbon. So yes, the number, the degree or primary, secondary, it only depends on the number of carbons you are attached to. This much we are clear? Okay. Now, what will be the secondary amine, guys? Can you give it a try? What will be a secondary amine formula? So the structure will be like this, 2 alkyl groups connected. This will be a secondary amine. Yes or no? Right, guys? Correct? Alright. Now, can you tell me what is the degree of this amine? Let's say I've written CH2CH3 over here. Okay. Can you tell me what is the degree of this amine? Tell me. Secondary, no? Why secondary? Because there will be 2 carbon connected. Yes or no, guys? There are 2 carbons connected, no? That will be also your secondary amine. Everyone, is it clear? Is it clear? It's wrong. Why is it wrong? Tell me. It is wrong because I told you, see how many carbon nitrogen is connected to. Not how many carbons are there in the entire molecule, right? How many carbons nitrogen is connected to. How many carbon nitrogen is connected to right now? Only 1. Maybe there are 2 carbons, that is true, but only 1 is connected to nitrogen, isn't it? So the answer will be, it will be 1 degree carbon. Is it clear? 1 degree is also known as primary. This much do you know. Okay, so this is primary, this is secondary. So what will be a tertiary nitrogen, guys? Tertiary will be connected to 3 carbons. Yes? Yes, everyone? It will be connected to 3 carbon, 3 alkyl group. It can be anything. I hope you know that nitrogen has a lone pair, right? How many lone pair do oxygen have? I told you this in the last session, guys. Oxygen looks like Mickey Mouse, right? So it has 2 lone pairs. You remember the question of hydrogen bonding we are doing? How many hydrogen bonding centers are there in the water molecule? If you feel like, see, let's say you're in the video for the first time and you feel like these things you are being able to connect with, then it is all fine, right? You can continue with this video. If you feel like that, sir, I feel maybe you are talking about all these things, I feel like understanding, but I'm not really being very comfortable with it. In that case, guys, I will suggest you to go and watch the previous video first, okay? That will be much more helpful for you. So this is your actually tertiary amine, right? This is your 3 degree or tertiary amine. So let's talk about this topic now, okay? So let me get rid of this. Okay, this was the question, right? Okay. Now, guys, we were solving the question like we have a 2 degree amine and I guess you could understand now this is a 2 degree amine. Just a second. Yeah, you could understand now this is a 2 degree amine. CH3 whole 2 NH. This is how they are writing. CH3 whole 2 NH. What do we mean by that? In a bracket they are writing now. That means the molecule is N. There is a lone pair always present in nitrogen. Then hydrogen. Then a CH3. Then another CH3. That is CH3 whole 2 N. Correct? Right, everyone? That is CH3 whole 2 N. And the other molecule they have given CH3 whole 3N. Can you tell me what is the degree of this amine? This was your 2 degree amine, correct? What is the degree of that amine? Very good. All of you got it right. It is 3 degree amine, correct? CH3, CH3, CH3. So that will be your 3 degree amine, right? Very good. So the question is now that what will be the basicity order, right? In an aqueous solution. What will be the basicity order in an aqueous solution? Now, guys, I want you to be very much attentive with me here because this is a very, very important question, right? So, this much I guess we can get rid of now. Okay, now see, let me take a yellow ink. Let's see, guys. When they say aqueous medium, what do we do generally in that situation? See, generally first if I talk about in gaseous medium what happens. I'm teaching you both in gaseous medium and also in the aqueous medium. I'm teaching you both the cases right now, okay? So stick with me here. If I'm talking about the gaseous medium, what will happen? Let's say I have a 3 degree amine. Let's say I have a 3 degree amine. Then I have a 2 degree amine. Then I have a 1 degree amine, okay? So let's say I have these 3 amines over here. Now guys, let's say I asked you, what will be the order of basicity under these circumstances? This question also comes very often in boards, right? So what will be the order of basicity under these circumstances? What is basicity, guys? Okay, I forgot to write the lone pairs. Okay, what is basicity, guys? See, basicity is nothing but electron donating ability. What is basicity, guys? Very, very important point. Electron donating ability. Let's say, how do we understand basicity? Let's say, guys, you have 100 rupees in your pocket, correct? So let's consider 100 rupees as the electrons. Okay, just compare these two things. Now, who's a basic? Which of the molecules are basic? So let's say you are a generous person, you are a benevolent person. What will you do? You will donate your money to the people who needs it, correct? That means the people, those who can donate their money, they are called the benevolent person or the generous people, correct? There are so many people, those who does that. Now, similarly, there are some molecules, those who are generous enough to donate their lone pairs or electrons or any form of electron. It can be lone pair, it can be just one electron, it can be a pair of electron, it can be anything, right? So under that circumstances, guys, we can call them a basic molecule. Okay, so question is, this electron pair that nitrogen have, in which case can it donate? The nitrogen's lone pair, in which case will it be able to donate? That's the question. So can you give it a try, guys? Can you just pause this video for a second and can you give it a try? In which case the electrons can be donated very easily? Okay. Now, how to deal with it? See, if I have a CH3 molecule, you know, guys, CH3 shows electron donating ability known as plus I effect. So they are electron pushing groups, isn't it? So you can see there are 3 electron pushing groups towards nitrogen. So how many, guys? 3, right? 3 CH3s are there. So there are 3 plus I effect showing group. So what will happen? Because of this CH3, as they're pushing the electron cloud towards nitrogen, what will happen because of that? This nitrogen will be electronically rich. This nitrogen will be electronically rich. Yes or no? If this nitrogen become electronically rich, then what will it do? It will be able to donate very well. It will be able to donate the electron cloud very well. Did you understand this, guys? Let me tell you an example here. Let's say you got very good marks in your boards, right? So in that case, what will happen? Let's say you got your parents, your mom said that, you know, you got so much of a good marks, you got 95%, you got 98%. So for that, what will I do? Let's say I will give you some pocket money, right? So let's say right now you have 100 rupees in your pocket. Now what happened is you wanted to donate it to people. You wanted to do some charity with it. But when your parents are giving you, let's say your mom is giving you 100 rupees, then how much do you have now? 200 rupees. So you're richer now. So you can donate more money to people. Do you get the point here? Similarly, let's say your dad also decided that he is also going to give you 100 rupees more. It's your dad. So 200 rupees more, right? So now how much money do you have? 400 rupees, right? Did I do the maths correct? Yeah. You have 400 rupees now. So now you are even richer. So you can donate even more at this moment, correct? So these people are electron donating. So when you have electron donating groups, they will make you rich. They will make this nitrogen rich and the nitrogen will be able to donate more. Is that clear? Similarly now, here guys, how many electron donating groups are there? Only 2 plus I effect showing group. So it will donate, but it will donate lesser than this now. What about this guy? It will donate even lesser than this. Is this clear? So this will be your 3 situations over here. So the order of basicity in your gaseous medium, guys, very, very important. In the gaseous medium, this will be the order of basicity, correct? You can try out the basicity questions of organic chemistry now as well. Okay, you can apply this small example, this small concept that if you have electron donating groups, then the molecule will be basic. And on the other hand, guys, if you have electron withdrawing group, then the molecule will be acidic, right? Very good. Now, this is your gaseous medium order, 3 degree, 2 degree, 1 degree. Okay. Now, we are going to talk about the aqueous medium. This is the question that often comes. Gaseous medium is simple, but the aqueous medium is what they ask, right? So, under that, what you are going to do? So, let me erase everything. So, what will happen in aqueous medium? Okay, I'm going to take an example over here, right? Let's say there is a boy, okay, there is a boy who has his exam and this is his exam center. Okay, so he has his chemistry exam and this is his exam center. Okay, now this boy has prepared very well. He is prepared for 100% marks. He has prepared for 100% in chemistry, which is all of your dream, right? So he has prepared for 100% in chemistry. Now, what happened is he slept a little bit more, or let's say he started a little late. And because of all this reason, he couldn't reach to the place. Let's say because of all this reason, he couldn't even reach the place. Will he be able to get 100%? His preparation was very well. The preparation was to get 100%. But he couldn't even reach to the examination hall. Will he be getting 100% marks, guys? No, right? Okay, this is case 1. This is your case 1. Let's talk about case 2 here. let's say there is another guy. Let's say there is another guy over here. Now, what's the problem with him? See, he reached the examination hall 1 hour before. 1 hour before. But he didn't even prepare for the exam. Will he get 100%? Forget about 100%. Will he even pass? No, right? So, he won't be able to get 100% either. Right? So, you need to have your preparation. Also, you have to reach to the examination center. Both the process has to be there. Correct? Now, let's talk about case 3. Okay. Which we are all under. Okay. There what happens is, this guy, what he has done is, his preparation is fine. Not at 100% level. Preparation is fine. Let's say 90% level. It is preparation. And he reached to the exam center also 1 hour before. Who will get the maximum marks, guys? This guy hasn't even appeared. With the 100% preparation, he hasn't even appeared. This guy has appeared but won't get marks because he hasn't studied. But this guy has not studied like this person. He has not studied like case 1, and he has reached to the examination center also. So he will be the one getting the highest marks. Yes or no, guys? He will be the one getting the highest marks. Now we are going to take this anecdote. We are going to take this anecdote for this example, right? So see, if I take you to the next slide here, I'm gonna need that picture. When we talk about, let's say, basicity, this is the only question that comes, guys, okay, about aqueous medium. Basicity in aqueous medium. When we talk about the basicity in aqueous medium, what are the 2 things we need to take care of? Okay. First point will be, point number 1 is solubility in water. First point is solubility in water. Second point is basicity. See now, let's say one particular molecule is very much basic, but it is not soluble in water. Which case it is, guys? The case 1. The student has studied everything, but he hasn't even reached to the examination hall. So in that case, will it be basic? If it is not soluble in water, but very much basic, will it show basicity in water? Common sense. No, right? Okay. What was the case 2, guys? Case 2 was, his preparation wasn't there, but he was there in the examination hall. So here, let's say someone is very much soluble in water, but it is not that much basic. So will it show high basicity? No. So who will show the best basicity, guys? Who is soluble in water, also having basic nature? We have to find that guy, okay. See now, what was the basicity order? We have just learned, guys, 3 degree, 2 degree, 1 degree, isn't it? Tertiary has the highest basicity. Why? Because it has the most amount of electron donating group. Because of that, it is the most basic in there. Correct? This much we are all clear? Okay. Now the point is, if we talk about solubility now. Now what will be the solubility order? So guys, I told you in the previous class, when we talked about this aniline question, I have talked about that. There I told you, how do we figure out the solubility? Solubility, all the physical property, guys, it depends on the hydrogen bonding, right? Solubility depends on hydrogen bonding, okay? So if you have watched my previous video, can you try this question? Can you tell me, if I'm writing this nitrogen with let's say 2 hydrogen and 1 CH3, what is the degree, guys? 1 degree, right? Can you tell me how many hydrogen bonding centers are there? How many centers of hydrogen bonding are there? Pause this video and give it a try, everyone. How many hydrogen bonding centers do you see? Okay, see, 1 center from the lone pair, 1 center from this hydrogen side, 1 center from this hydrogen side. So how many hydrogen bonding can it make, guys? 3. How many? 3. Correct? Okay. Now, if I make a 2 degree amine, how many hydrogen bonding can that guy make? Tell me. Tell me, guys, how many hydrogen bonding can that guy make? So it will be able to make 1 from the lone pair, 1 from the hydrogen. So how many? 2. Can you tell me now how many hydrogen bonding a 3 degree amine can make? Give it a try. Very good. I guess all of you have got the answer as 1, right? Only from the lone pair center, right? Acha, who are they making hydrogen bonding with, guys? They are making hydrogen bonding, but with whom? With water, right? Because we are talking about solubility now. So they are making hydrogen bonding with water, okay? They are making hydrogen bonding with water. These are the oxygen centers they will make. I hope you can relate it with the previous question, guys, previous video also. So these are the hydrogen bondings that we can make here, correct? So considering that, guys, here 1 now, 1 hydrogen bonding only. So guys, tell me, which one is the most soluble then? definitely whoever makes more hydrogen bonding is the most soluble. So can I say solubility order, who is making the highest number of hydrogen bonding guys? 1 degree, then 2 degree, then 3 degree. So guys, basicity order is 3 to 1, solubility order is 1 to 3. So what will be the final answer then? See, 1 is soluble, the most soluble amine, but it's the least basic. Case 1. You have studied 100% but you couldn't reach to the center, right? If you talk about 3 degree amine, it is the least soluble but the most basic. Case 2. So who will win the race guys? The race will be won by 2 degree amine, isn't it? So the final answer will be 2 degree amine because it can be soluble in water. Also it can show basicity, correct? So 2 degree will be winning. Now the next question is who will come next, or whether 1 degree will come next or 3 degree will come next after 2 degree. So that depends on the alkyl group that you have guys. Let's say if you have methyl, for that it will be 2 degree, 1 degree, 3 degree. And if you have ethyl, then it will be 2 degree, 3 degree, 1 degree. Okay, so this will be the way to solve this question. So if I go back to the previous question, so what was the question over here? They have given the 2 degree amine. So guys, what will be the answer? They have given a 2 degree amine here, they have given a 3 degree amine here. Which one has more basicity in aqueous medium? The answer is 2 degree. I hope we could understand. So 3, 2, 1 in gaseous medium. In aqueous medium, 2, 1, 3 if it is methyl group. 2, 3, 1 if it is ethyl group. What do I mean by methyl and ethyl group guys? So I think I have deleted that. Okay, this group is called methyl, no? What is an ethyl group? Let's say I have CH2CH3, that is called ethyl group. If I had CH2CH3 over here, that would have been called as the ethyl group. Is that clear to all of us? All right, great. So that's how you answer that question. Let's move on to the next one now. Okay, give reasons for the following. The melting point of alpha amino acids are generally higher than that of the corresponding carboxylic acid, and amino acid shows amphoteric behavior. So the first question is coming from hydrogen bonding. Okay, the first question is coming from hydrogen bonding. The melting point, again, the moment you see boiling point, melting point, these related questions, now always think about the hydrogen bonding there once. Okay, see, I'm gonna make a clear segregation in your mind, right? Whenever the physical property question comes, okay, I'm talking about organic chemistry chapter right now. Let's say physical properties of organic chemistry is given to you. Okay, whenever the physical property of organic chemistry is being given, for haloalkanes, haloarenes, there will be no hydrogen bonding. So if it's a physical property question of haloalkane, haloarenes chapter, there will be no hydrogen bonding, right? Why? Because for hydrogen bonding we need FON, correct? So for haloalkane, haloarenes, there will be no hydrogen bonding. But for the next 3 chapters, that means alcohol, phenol ethers, aldehyde ketones, carboxylic acid, and the amines or the nitrogenous compound. In these 3 chapters, all the questions, all the physical property questions can be catered by hydrogen bonding. Did you understand this? Right? Same thing you can do in biomolecules also. So I'm going to show you what to do with this question. Alpha amino acid. What do I mean by alpha amino acid? First you understand that. What is amino acid? That we all know. See, whenever, let's say you have a carbon, there is a COOH group connected and there is an amine group connected, that will be called as an amino acid. Okay? Whenever there is a COOH and NH2 connected together in a molecule, that could be called as an amino acid. So the other two will be a hydrogen and an R group. This much we all know. What is this R group? Again guys, it will be alkyl group, different alkyl group. So that is the basic formula of amino acid. Now what do I mean by alpha amino acid? So how many types of amino acids are there guys? Alpha, beta, gamma, delta. All these types of alpha amino acids, all these type of amino acids are there. Okay. So what do I mean by alpha amino acid over here? Okay. See, alpha means, let's say this is my functional group. You know guys, with respect to the functional group, the very first carbon is called alpha. So if you have the amine connected with the very first carbon, if it is connected to the alpha carbon, then we will call it the alpha amino acid. As simple as that. Okay. What if this amino acid, this amine group, let's say I am trying to make a molecule for you, COOH, let's say, here the NH2 is connected. Can you tell me what will be the name of this amino acid now? This will be beta, because this is my functional group, right guys? With respect to this is alpha and this is beta. Yes? Very good. So alpha, beta, gamma. Gamma means COOH, alpha first carbon, beta second carbon, gamma third carbon. So if the NH2 is in the third carbon, that will be called as your gamma amino acid. As simple as that, right? Okay. So what are they asking the question for? Again, the question was asked as, so I'm just going to get rid of this, need the rest of the part. Okay. Now, the question is being asked as the melting point of alpha amino acid and generally higher than that of the corresponding carboxylic acid. Why? See guys, if you notice in the amino acid, and if I draw the carboxylic acid also, CH3, COOH. Okay. So in see, whenever I try to solve this kind of question, I can actually explain this entire question to you. That will take a lot of time. Let's just be smart over here. Let's just make a smarter approach to this question. See, what I'm going to do is, this COOH part is common in both of them. Na? So if that is common in both of them, there is no point of talking about COOH. See, if I ask you, what is the difference between me and your physics sir? What will you say? Will you say the same thing, sir? You have 2 eyes, sir has also 2 eyes, you have 2 ears, sir also has 2 ears. Will you say these kind of things which are common? No, no. You will say, sir, you have a beard, maybe sir has a bigger beard than you. Which is the comparison we make with the things that is different, not the things which are same, correct? So considering that, COOH part is same in both the cases, right? What is different? This guy has an NH2, this guy doesn't have an NH2. And now guys, what will happen if you have an NH2? What can you do? You can do hydrogen bonding. How can you do hydrogen bonding? Because if I draw, let's say anything is connected to NH2, so how many hydrogen bonding can you make guys? Hydrogen bonding centers will be 1, 2, 3. So because there are 3 hydrogen bonding centers present in this NH2 group, that's why what happens is all the physical properties will increase. See, how do we actually understand about this boiling point and melting point? Okay, let me take a prompt for you. Let's say I have 2 bottles of water. Okay, I have 2 bottles of water, right? Let's say, what is this melting point? What is this boiling point? See, if I say there is a solid, there is a liquid, there is a gas. What's the difference between them? Solids are strictly connected to each other. Liquids are a little bit far away. Gases are even far away, right? So if I'm saying boiling point, what am I trying to do? I'm trying to, let's say this is your liquid, this is your gas. So what am I doing here guys? From liquid to gas, I am setting them apart, isn't it? Now if you understand that, let's say these 2 are making hydrogen bonding between themselves, what will happen? Will I be able to set them apart that easily? Let's say they're holding on to each other, right? They're friends with each other. Will I be able to separate them that easily? No, right? So that's why whenever hydrogen bonding comes into the picture, the boiling point, the melting point, all of them rises. You have to give more energy, more heat to take them out, to separate them out. Is that clear? Okay. So here there will be more hydrogen bonding, and that's why 3 more you can mention, 3 more hydrogen bonding per center, okay, per center. So that's why it will be having your higher boiling point. This is done, higher melting point. The amino acids show the amphoteric behavior. This is not a part of this discussion, right? This is because of the zwitter ionic formation, right? I will talk about those also in the coming videos. Okay, all this question I'm solving are there from the same paper, okay? So the question is now, assertion reason. The boiling point of ethanol is higher than that of methoxymethane. The boiling point of ethanol is higher than that of methoxymethane. So guys, what is ethanol? Ethanol is you can pause this video and give it a try. You can pause this video and give it a try. If I'm talking about ethanol, ethanol is actually your alcohol, right? Ethanol is actually your alcohol. And what is this? Methoxymethane, guys. Methoxymethane. Can anybody tell me what kind of molecule is this? Is it an ester? See, we always make mistakes between esters and ethers, isn't it? This is an ether. Methoxymethane. Methoxymethane. Between alcohol and methoxymethane, they are asking which one has the higher boiling point. Again, boiling point they asked. Boiling point they asked. They asked from the alcohol chapter. So what will be the answer? Hydrogen bonding. Let's say you don't even know the answer. You don't even understand much about hydrogen bonding. You just write hydrogen bonding, you will get 1 mark right there. Right? Smart, isn't it? So that is how we need to approach every question. Now guys, ethanol. Let's draw this. Ethanol. Ethanol means 2 carbon alcohol. This, can you tell me how many hydrogen bonding is it capable of making? How many centers are there? 3. 1, 2, 3. Okay, one thing I want you to notice here, guys. Whenever they talk about boiling point means what I said? 2 same molecules, you have to separate them. That is called boiling. So whenever they talk about boiling point, you are going to make the hydrogen bonding only between the same molecules. only, not between, I should say only among the same molecules. What do I mean by that? See, if I have solved the question of solubility previously, there with whom were we making the hydrogen bonding? With water, because we are dissolving something in water, correct? Here are we dissolving? Is this a solubility question? No, no. It's a boiling point, melting point question. When we talk about boiling point, melting point, it will be between the same molecules. You cannot take water here. So it will be 2 ethanol molecules, 3 ethanol molecules, 4 ethanol molecules. In between them, you have to make the hydrogen bonding. So if I make the hydrogen bonding for this system, then it will be making with the oxygen of ethanol. Acha, this lone pair will be making with a hydrogen of ethanol, and this lone pair will be also making with the hydrogen of ethanol. Guys, this structure you need to practice, okay? You have to draw these structures when this time comes, or when the question comes, okay? So how many hydrogen bonding centers are there? 3. How many hydrogen bonding it is making successfully? Answer is 3. 3 it is making, right? What about methoxymethane? Can you tell me, guys, how many hydrogen bonding centers are there in methoxymethane? How many centers are there? What is the capability of this molecule of making hydrogen bonding? The answer will be 2, right? 1 from here, 1 from here. 2 lone pairs, correct? No hydrogens present, so no hydrogen bonding there. You might say, some of you might have this question in your mind that, sir, we have hydrogen present here. We have present here, right? So guys, I told you the hydrogen has to be connected with FON, isn't it? Is this hydrogen connected with FON? No, no, it is connected to the carbon. So it's not that, right? This hydrogen is connected to the FON. You have to have this connection has to be with the FON elements, right? So here 2 centers are there. So how many centers, guys? 2 centers. That's not the problem. Problem is, can it make hydrogen bonding with itself, not with water? With water, if I give, it can make 2 hydrogen bonding. But we are saying with itself, na? So with itself, can it make hydrogen bonding? The answer is no. Why? Because see, this lone pair will be able to make hydrogen bonding, but where is the hydrogen to make one? There is no hydrogen, na? You might say, sir, there are the hydrogens present in the carbon. I agree, there are hydrogens present in the carbon, but it cannot make the hydrogen bonding with the hydrogen present in the carbon. It has to be connected with FON, not with carbon, isn't it? So these centers might be 2, but it cannot make any hydrogen bonding with itself. With water, yes, it can. If I just consider water, water has the hydrogen connected to oxygen only. So with water, it can make hydrogen bonding, but with itself, it cannot make hydrogen bonding. Did you understand my point, guys? So I'm going to just write it down for you. This is a very, very major point of discussion, right? So how many hydrogen bonding will it be able to make, guys? Then in the end, it will be able to make 0. It has 2 centers, but it will be able to make 0. So it can make 3 hydrogen bonding. These guys can make 0 hydrogen bonding. So which one will have higher boiling point? For sure, ethanol. Ethanol will have the higher boiling point. Okay. What is the reason? Achha, this is the assertion reason, na? There is intramolecular hydrogen bonding present in ethanol. Is it intra or is it inter? It is inter, right? Intra was orthonitrophenol, last video. Orthonitrophenol we have talked about. There it was intramolecular hydrogen bonding within the same molecule. But here, this is one molecule, this is another molecule. So what kind of hydrogen bonding is this? Intermolecular hydrogen bonding, okay? So it will be intermolecular hydrogen bonding, not intra, okay? That was it. So I guess this question, the answer will be assertion is correct. This assertion, that is correct, but the reason is wrong. Assertion is correct, but the reason is wrong, okay? Let's move on to the next question. I hope you guys are feeling a little bit confident. Okay. Now I told you, rather than other than this physical properties of organic chemistry, that is where the hydrogen bonding will be seen the most, but it will also come in physical chemistry chapters also. It will also come in physical chemistry chapters also. So if you notice, for this particular question, what are they writing? The question down below. So in physical chemistry, I told you guys, in the chapter solution, there is a topic called Vant Hoff factor. There is a topic called Vant Hoff factor. Being denoted with an I, right? Now, if I talk about Vant Hoff factor, you are aware that Vant Hoff factor is something which talks about association and it talks about dissociation, right? It talks about these 2 things. Now, when we talk about association or dissociation, you can understand we are gonna be needing hydrogen bonding there also. I'm gonna show you how. Let's talk about this particular question. The freezing point of a solution containing 5 grams of benzoic acid. The freezing point of a solution containing 5 grams of benzoic acid. What is benzoic acid, guys? Benzene with a COOH, right? Benzene with a COOH. That is your benzoic acid. Molar mass and everything is given, fine. in 35 grams of benzene depressed by 2.94. So what are they trying to say, guys? They're trying to say it's a question of colligative property, correct? It's a question of colligative property. From which topic is the question coming, guys? The question is coming from depression of freezing point. First, to identify things, it's a depression of freezing point. For depression of freezing point, what was our formula? The formula was delta TF is equals to I into KF into M, correct? This was your formula there. Acha. Now, what will be the M over here, guys? M is molality, not molarity, it is molality, right? Molality. What is molality? Molarity is number of moles of solute present in 1 kilogram of solvent. Number of moles of solute present in 1 kilograms of solvent, yes or no, guys? So if that is true, then can I write it in this way? Number of moles of solute, B for solute, in mass of solvent in kg, can I write in this way? A is your solvent, B is your solute. A is your solvent, B is your solute, okay? So can I write it in this way? Yes, I can. Now NB can be written as WB by MB, mass by molar mass, right, guys? Now see, all the values are given to you. See, mass of solute is given to you. Let me change the color. Mass of solute is given to you. WB is given to you. MB is given to you. WA is also given to you. So all the values are given to you. So you can easily find out the molality from here. Yes or no? You can easily find out. Can you just quickly correct for me? Just quickly find out the molality from here. See, the KF value is also given in this question. So that is also given. So what is not given? The I value is not given only. So see, I haven't even read the entire question yet. But by just looking at the type of the question, I could right now know that the question will be coming based on the Vant Hoff factor only. Let's see. Let's see the rest part of the question. Calculate the percentage association. What is this? Alpha. Degree of association, degree of dissociation of benzoic acid. Percentage association of benzoic acid. How do we solve this question? See, Vant Hoff factor I can be written in terms of association as in terms of dissociation also. See, we will also make videos for this numerical solution also. Okay, that is there in my list. We are going to talk about those type of videos also. So there I will show you about all this Vant Hoff factor, all the calculations and everything, how the things comes. But right now for association, the formula that we follow is 1 minus alpha plus alpha by n. This is the formula we follow, where alpha is your degree of association. Your degree of association is called alpha. What is n, guys? N is the number of particles associating. Number of particles associating, that is your n. Okay, degree of association and number of particles associating. Okay, stay put, guys. This is our last question of this video over here. So alpha is the degree of association and n is the number of particles associating. Now if you notice in the question, guys, they have said benzoic acid forms a dimer. It forms a dimer solution. Guys, this is something you should know. All the carboxylic acid, they forms dimer with the help of hydrogen bonding. Now, how do they make the dimer? This structure is there in our organic chemistry in aldehyde ketone carboxylic acid chapter, and it is also there in our solution chapter also. So if you notice over here that there are two intermolecular hydrogen bonding being formed, two intermolecular hydrogen bonding are being formed to connect two benzoic acid system. Can you just recognize it, guys? See, this is your benzoic acid, one benzoic acid. This is the other benzoic acid, right? These are the two hydrogen bonding made in between them. What kind of hydrogen bonding is this? Intramolecular or intermolecular? It would be intermolecular. Between two molecules, na? It will be your intermolecular. Okay? So because of this hydrogen bonding, the number of molecules attached with each other is n. N is 2 over here. They are making dimer. They will always make dimer. So guys, in this question, the value of n is going to be 2. You have to find out what is the value of alpha from here. That's the question, right? So again, one more time, the delta TF was also given. Na? What was the delta TF? 2.94. So see, you have the Kf value, you have the M value, you have the delta TF value. You find out what is going to be the I value. Once you find out the I value, you put it in the next equation. In here, you put that I value over here, 1 minus alpha plus alpha by n. N value is given as 2. You have to find out what is alpha. See, my point is not to solve this question. For that, though, I'm going to make a dedicated video going forward, right? My point was to make sure you see that over here also you have the hydrogen bonding present in there. So that's why, guys, we have taken this particular concept for our consideration, and this is a particular concept that covers up multiple chapters going forward. If you like this kind of video and if you want to watch more of this kind of video, go ahead and check our Nsmart app in the Play Store. We will be launching another video very shortly, and I want you to guess what will this video is all about. It is going to be something that you might all be waiting for, right? We are going to talk about something very special. I want you to keep guessing about it, and I will be releasing this video very, very soon, very shortly. Till then, guys, bye-bye for today. See you then in the next video. Bye, everyone.